In today's session, we are going to discuss about some problems about electromagnetic induction, EMI. So let us have a look on some of the problems. Question number 1. So a circuit is shown like this. So there are inductors in the circuit as shown. I'm going to display the problem over here. You can just go through that and then solve this problem. These two are connected in parallel. You know that when they are connected in parallel, the formula is for L dash, L effective is L1 by L1 plus L2. So it is nothing but 5 into 10 by 5 plus 10. So 5 into 10 by 15, it is 10 by 3 millihenry. Now in the steady state what happens is, understand this concept that in steady state, that is t is equal to infinity, steady state, inductor behaves like a open wire. Okay, open wire. This is the concept. Now the current distribution, that means these two put together will look like this, right? This value is how much? 10 by 3. And at steady state this will behave like a wire. So there will be no resistance in the wire here. So the current will be I is equal to total voltage by resistance, which is the voltage is given as 20 volts by resistance is 5, so it is 4 amps. Now the next step would be, is asking you what is the current that is going to the 5 millihenry. Through this inductor how much current is going. So for that the concept is I1 is to I2 is equal to 1 by L1 is to 1 by L2. This is something similar to what you have done in the resistor circuits. Okay. So this would be like 1 by 5 is to 1 by 10, which is multiplied with the LCM, 10 is to 5, which is 2 is to 1. So the current that is flowing through this would be 2 by 3. Through this, it will be 2 by 3 of the total current, total I, which is 2 by 3 into 4, 8 by 3 amps. Okay. So here second question will be displayed. Just have a look on that, then we'll discuss. So let us have a look at the second question. In this question, as you can see, if you read the question, he is asking you what are the currents that are flowing in the circuit at t is equal to 0 and t is equal to infinity. Now t is equal to 0 means initial state. This is defined as initial state, and t is equal to infinity means this is called steady state or final state. Okay. So in the initial state, the current through the inductor will be 0. The inductor won't allow. Inductor won't allow any current initially. Initially it won't allow any current. In the steady state what happens is, it is completely like energized and it behaves like an open wire. That means this is the inductor, no? It will behave like open wire. R is equal to 0 in this state. So in the initial state what happens, we have to see in which part the current is actually going. So we can put some names here, A, B, C, D. This is E and this is F, G. So in the initial state, what happens is, this inductor won't allow the current. So current won't pass through this. So the path for the current would be A, B, F, G, E. So you will have this resistor and this resistor participating in the flow. So both are in series. So the effective R will be 20 plus 10, 30. And the current will be voltage. Voltage is 2 by 30, 1 by 15 amps. In the steady state what happens is, this will behave like an open wire. Okay. So the current will not go through this resistor, it will go through this inductor. The path would be A, C, D, E. In this path it will go. It will go in this path, and this will behave like a wire. So only one resistor will be there. Okay, so in this situation, the current at steady state will be equal to 2 by 20, which is equal to 1 by 10 amps. So the third question I'm going to display over here. Okay, let us have a discussion on that. So in this question, he is asking you what is the current, that is induced current, that is flowing through the circuit. So this type of problem, first of all, you need to understand that we need to, what is this symbol? This symbol is for slider. Okay, this is a fixed frame. This is a fixed frame, and this is a sliding conductor. Okay, this is a sliding conductor. So what happens is, when there is a movement due to the concept of this motional EMF, some induced EMF will come into the conductor. Okay, this R is the internal resistance. R is internal resistance. So initially, what happens is, if you try to understand, this is the fixed frame. Okay, so we can write like this. VAB is equal to VCD. These two are parallel. These two resistors are parallel. So the effective resistance will be equal to R dash is equal to R1 plus R1 into R2 by R1 plus R2. Okay, so that is about this and this put together. So we can here finalize what is the high potential point. For that we have to use the right hand palm rule. So it is like this, So let us say this is your right hand. Okay, so this indicates the motion, and this indicates the field. So the white portion is there, no? The upside part will indicate the high potential part. So if you put like this, so you see this is into the board, right? So the tip of my fingers will point towards that, and my thumb will point towards the motion, which is this. So the high potential point will be the upside, because the white portion of the palm is in the upper side. So this is plus and this is minus. Okay, so this circuit will actually look like this now. So let me draw it. So high potential, low potential, and then you have internal resistance, and then you have R dash. This is R dash, this is R, and this is E, which is equal to BLV, right? So for this, we have to find out what is the current. So current will be equal to total voltage divided by the total resistance, which is R plus R dash, because this and this are now in series. So E is equal to BLV as per motional EMF, and R plus R dash. R dash we have calculated here. So it is R1 into R2 divided by R1 plus R2. So if you simplify this, BLV, this will go to the numerator, R1 plus R2 divided by R into R1 plus R2. I am just taking the LCM now, plus R1 R2. This is the induced EMF in the circuit. This is the current in the circuit now. Okay.